All right, so AI models have gotten just unbelievably good at talking. They're fluent, they sound super confident, they can sound like absolute geniuses. But that brings up a huge question, maybe the biggest question. How do we actually know they're right? And not just, well, making it all up. Today, we're going to build the very tool that helps us tell the difference.
And really, this is the core challenge right here. You've probably seen it yourself. An AI gives you this long, detailed answer. Is it actually brilliant? Or is it just an amazing bluffer spinning up some convincing-sounding nonsense? I mean, if we're ever going to truly trust these systems, we have to be able to answer that question.
This slide just lays it all out perfectly. Think about it. On one side, you've got an AI that sounds convincing, It uses all the right jargon, has a confident tone, the whole shebang. But on the other side, that's what we actually need. An AI that is correct, factually, logically, verifiably right. And bridging that gap? Wow, that is one of the biggest challenges in AI right now. So how do we even begin to solve this? Well, we build a specialist. And that's going to be the hero of our story today, a tool we call a verifier.
You can think of it like an AI fact checker, but one that's specifically built to grade an AI on its math skills.
Now, it's not like there's just one way to check an AI's homework. There are tons of tools out there for evaluating these models, things like public leaderboards or even having another AI act as the judge. But for today, we're going to zero in on verifiers. Why? Because they're just so powerful for anything that requires careful, step-by-step reasoning.
So, what exactly is a verifier? The easiest way to think about it is like an automatic grading machine. It just takes the AI's answer, checks it against the actual correct solution, and then stamps it with a pass or fail. It's that simple. And math is the absolute perfect place to test this out because, unlike an essay, a math problem has a clear, definitive right or wrong answer.
Okay, so let's get into the nitty-gritty. How do you actually build one of these things? We're going to go inside the verifier pipeline and really break down the critical steps. This is how we take a messy, raw output from an AI and turn it into a clean, verified grade.
So here's the roadmap, the big picture. The whole workflow starts with that raw text the AI spits out, and it all ends with a simple true or false. We're going to walk through the most important parts of this journey, pulling out the answer, cleaning it up, and then finally, checking if it's right.
You can really boil this whole thing down to 3 critical steps. It's actually pretty straightforward. Step 1, we got to find the actual answer, buried inside the AI's big, long explanation. Step 2, we have to clean it up and get it into a standard format. And step 3, we use a powerful math engine to do the final check.
All right, let's tackle step 1, extracting the answer. See, the AI doesn't just give you a number. Oh no, it gives you its whole thought process, the chain of thought. So our first job is kind of like a treasure hunt. We have to dig through all that text to find the final answer. And luckily, it's often put in a special boxed format to help us out.
And here's a peek at what's happening behind the scenes. Our verifier is basically scanning through all that text, looking for that specific command. Once it finds it, boom, it just grabs whatever is inside the brackets. It's a really neat trick to isolate the final answer from everything else.
Okay, on to step 2, normalization. And we're not done yet, not by a long shot. Just because we found the answer doesn't mean a computer can read it. Think about it. An AI could write 14 divided by 3 in a bunch of different ways. So we have to convert all those different styles into one single standard format that our program can easily understand. So what we do is take that kind of fancy math notation and we turn it into something super simple that a program can read, like just parentheses 14 divided by 3. This is so important because it means that no matter how the AI decides to write the fraction, it all looks exactly the same to our verifier in the end. Standardization is absolutely key here.
And that brings us to the grand finale, the most important step of all, verification. Now here's the tricky part. We can't just do a simple text match. I mean, what if the AI answers 28 divided by 6 when the correct answer is 14 divided by 3? A dumb text check would say that's wrong, but mathematically, they're the same thing. And that's exactly why we use what's called a symbolic math engine. It's like a super smart calculator that actually understands the math and knows that those two fractions are identical.
All right, our verifier is built. Now for the really fun part. Let's put it to work. We're going to have a little competition. We'll test 2 different AI models, a regular base model against a specially trained reasoning model. And we're going to throw a really tough challenge at them, a set of 500 math problems.
And wow, the results are just staggering. It's not even a close fight. The standard Bayes model really struggles, only getting about 15% right. But the reasoning model, it absolutely crushes it, solving over half the problems correctly, scoring above 50%. We're talking more than a threefold jump in accuracy. That's huge.
Let's just let that sink in for a second. 50.8%. On a really tough math test, that is a massive deal. So what's the secret sauce here? Well, it's all in the training. Instead of just learning to predict the next word in a sentence, these reasoning models are actually taught to show their work, to generate those step-by-step solutions. And it's that focus on the process, not just the final answer, that builds real problem-solving skills.
But of course there's a catch. That amazing performance comes at a price. Just look at the time it took. The Bayes model, the one that wasn't very accurate, finished the whole test in about 13 minutes. The smarter reasoning model, it took over 3 hours. So that lays out a really clear trade-off we're facing right now. If you want more accurate, reliable answers, you've got to be willing to sacrifice a lot of speed.
And this, at the end of the day, is why all of this matters so much. A tool like a verifier lets us move past just being impressed by how well an AI can talk. It gives us a way to demand proof, to finally separate the models that just talk a good game from the ones that can actually get the right answer.
So that leaves us with a pretty exciting thought. We've figured out a way to automatically check an AI's math homework. What's next? I mean, just imagine applying this same idea to other really complex fields. Could we build verifiers for computer code, for scientific papers, maybe even for legal arguments? The journey to make AI not just sound smart, but be provably right is really just getting started.